Okay, now today we are going to start our new topic, that is software design. As we all know that software design is the third level of our SDLC model. Okay, first was feasibility study, second was requirement analysis and specification, and now the third one, that is our designing phase. Now what we know about designing phase? First of all the main thing is that up to now what we were doing was in the problem domain. That is, when the customer is giving you some problem, that is, he is giving you his requirements, the order of your software. At that time it was known as what? The problem domain. That is our feasibility study. At that time you are not going through the solution, you are not going towards the solution. Okay, that was the problem which was given to you as a software, in the form of a software. You have to make this software. You have the feasibility study, that I am going to make this software, how much feasible my software is going to be. So this is what is your problem is. Okay, now in the next phase, okay, you were also seeing that whether it was economically and technically feasible or not. That is also your problem statement. Now in requirement analysis and specification, what was happening? There also we were searching for what were our requirements to make the system a feasible one. Now the requirements are there, we were gathering the requirements, we were doing the analysis of the requirement, then we were having some specification, we were making the SRS documents. Okay, so these all things were what was in the problem domain. Now from this stage, that is our designing stage, what we are going to do, that is, it is coming to the solution domain. What that means? That is, if we were dealing with the problem till now we are making the solution for our problem. How we are going to make our software, the designing of our software. We have the requirement, we know how to make our system feasible. Now we have to see that how we are going to make our system, that is designing, coding, testing, etc, etc. So these things are going to be in your solution domain. That now what is this? What is designing? Software designing. Designing is what we are having the requirements in the requirement specification, SRS document, in the form of SRS document we have seen in our previous classes. Now what we are going to do, we are transforming those requirements into some other form. What form? By which we are going to make our coding. Okay, we are going to implement that thing. The output of this particular phase will be your whatever input that will be in your coding phase. Okay, that will be the input for your coding phase. In the designing phase, you are going to make the whole design of what we are going to do, how we are going to implement our software, how we are going to implement that one. So output of this particular phase, software design, we will see today what is happening inside that one. So output of this phase is going to be the input for your coding phase. How you are going to code your system, or you are going to make the whole system, that is what we do in the coding phase. What is this phase? We are going to make the whole architecture, whole design of how we are going to make our system. That will help you in the coding phase. So this transformation of our requirements, which was raw, we were only having the requirements from our customer. We were transforming these all requirements in a particular specific form, which will be helpful in the next phase, that is our coding phase. That thing we are going to, that transformation we are going to do in this designing phase. Done. Now one more thing, that is, here we will have some typical specific things, that is modularization and some concurrency type things, that we'll see now in next phase. Okay, now first thing, this whole designing phase is broken into mainly three parts, three levels or three parts. Okay, first one is architectural design. The first part of our designing phase is the architectural designing phase. After that we will go for the high level designing. Then the third one will be our detailed designing. As we all know, when we are going to do any kind of designing, so step by step, okay, step by step we do the designing, so that after the last phase we are going to get the output, which will be our input for the coding phase. Then, so what is going to be in this every particular phases? We are going to do some different kinds of things. So first of all, our architectural designing phase. What is there? It is the highest abstract version of our designing phase. means it's the highest version. Here whatever things we are going to do, we are basically changing our SRS document in a particular designing format. Okay, so that is our software design. So let's see next what is there. Identify software as system with many components interacting with each other. Here in the first thing what we are having the requirement for the whole system. This is the thing which we were done in our SRS document. We have the SRS document there. What our whole system is going to do, that is given in the SRS document. So we are working with the whole system, our whole software. Okay. Now what is happening here? Here we are seeing the software as some components, group of some components. Okay. These components, what they are doing their basic specific work. Okay. Here it identifies the software as the system with many components interacting with each other and working individually. They are working individually. Suppose someone is, if in our library management system we have seen previously, what is happening? Some components were working for the books. That is it was taking the function. We have seen there also the input it was taking. Some was giving the output. So these different components were working in a independent manner. They were doing their work separately. But what was happening? They were interacting with each other also, so that the output of one phase was going for the input of another phase. Okay, so this kind of interaction is done in a particular whole system. So at this level, we will see the whole system as some components interacting with each other. That is our architectural designing phase. Here we do with these all things. Now, designers get here the idea of proposed solution domain. As I have already told you, this is what is going to be your solution domain. From here onwards, you will get now you know what? This is my problem. I am going to deal with this problem. But from here onwards, you are getting the solution. How this is my problem, then how I am going to deal with this problem. Okay, so what the development team gets here? The development team basically gets here the whole proper thing what is going to be in our solution domain. We have the problem, now we will having the solution. That is the transformation which I have told you. This is what is called the transformation here. The transformation of the whole thing, that is the requirement analysis SRS document. Look what happens in the SRS document. What we were doing in the SRS document, it was what? It was specifically what our requirements were. Only the requirements. But for implementation phase, that is the implementation and coding phase, what is happening there? Some more specific requirements are going to be there. Okay, some more specific requirements you need here for this particular coding phase or your implementation phase. At that time, more specific requirements have to be there. Since at this time you are only having the requirements of the customer, but how you are going to deal with those requirements, how you are going to implement those requirements, that is your implementation in your software. For that, you have to add some coding. That is the coding phase. So these all things you need. What you need now, you need some more specification, some more requirements you need now. The requirement analysis given by your customers, okay. Now what? You need some more requirements, like which particular language you are going to use, which particular environment you are going to use, the particular testing environment, everything, testing cases, different things you are going to. Now you have some more specific requirements you are going to add it to your software, particular SDLC model. Now in this designing phase, so first of all, it's the highest abstraction level. Since it's the transformation part, so it's the highest abstraction level of this particular designing phase. Second one, what? It identifies that whole system is having many components. And those components, what they are doing? They are interacting with each other and doing their work individually. Okay. So after doing their work, they are giving the output to the other particular component. And again, that component is again working. So this thing is going on in this first phase. And third one, the designers are getting what? A proposed solution domain. Now, what solution? I have the problem. What kind of solution I am going to get? That particular thing, the idea is going to be achieved in the first level. Then So this is what is our architectural level of designing. Okay. Now second level. What is the second level? Next level, that is our high level. High level designing. What happens in this high level? Here we were seeing the whole system as a collection of components or a system with many components. Now what we are seeing here, it breaks. See, it breaks that particular thing. Okay, that here what was the many components? It was what a system with many components, single entity with many components. It is breaking that one, single entity, multiple component. It is breaking that thought now. It is breaking that one. That single entity with many components is now broken. Broken into what? Broken into what? Into less abstract view of subsystems and modules and depicts their interaction. Now what is happening there? There was a single entity. Suppose here what was happening? I was having a single entity. In this particular phase, I was having a single entity, and in this single entity, what was there? There were particular components. These are components 1, 2, 3, 4. These are particular components which are working here inside this particular system. Now what? We are breaking this whole thing. Now we are working with what? Now there is not a single system. You are not having a single system now. Now we are breaking this thing into particular different modules. These are my subsystems. Suppose now I'm breaking it into subsystems. This is my first subsystem. This is my second subsystem. This is my third subsystem. And what more? More thing is that these are my modules. These particular things are my modules. Understood? What is that one? Here the whole thing is, I'm working with the whole system. Whole system with some components. Now in the next level, I am going to break that thing. Single entity, many components. Break that one. Breaking in what? Breaking into some subsystems now. As we have done in integration testing, we were breaking the whole system. First of all, we were doing unit testing, small modules. Then in integration testing, we were merging those modules into some small components. And then after that, we were merging whole thing into a system testing. Now here the thing is going in another direction. That is the, here we are, first of all, we are working with the whole system. Okay. Now we are breaking it into module, small components, subsystem with modules, small modules. And what? Here also you have to see many things. We will study in your next class, cohesion coupling. Here also you have to see many things. That is, these particular modules, they are interacting with each other. Then these particular modules, they are interacting with each other. They have some force. They have some interaction between them, some communication between each other. Their particular input, their output. Again, that is going to another subsystem. Again, what? These subsystems are also having some interaction with each other. So, what is going here? The interaction between the subsystems and the interaction between these modules. This whole thing is going to be in your next level. Then in testing we were doing what we were doing? We were doing the with the first of all the modules, then components and subsystems, then what? The whole system. Here in reverse direction. That is whole system. We are first of all we are working with the whole system, breaking it into subsystems. Then in subsystems also we are working with their small modules. So here it is less abstract than the previous one. Previous one was the highest abstract level. Now here it is the less abstract level than that one. But it is breaking the whole thing. Single entity, multiple components. Breaking it into subsystems. Then again breaking it into different modules. What these modules do? This is what is called modularization. That is small modules. They are working individually. They have their task. They are doing their task individually, separately. They have been compiled. They have been executing. Everything is done separately. Again, they have some security system also for their own modules. But what is the main thing here? Their interaction, their communication with each other. Again, the communication between these subsystems are also there. So to deal with those particular things, we are having this high level design. Clear? Second thing, what? Implementation in modular form. we are implementing the whole system into some modular form. Modular form means breaking into modules, breaking into subsystems and then into modules. This is what is called modular form. So your system now, your whole system is now broken into small modules, and this implementation of these modules in your software, how they are working, how they are functioning of these specific modules, their specific function. So these things are going to be in the modular form. So this is what implementation is, modular form. Now third one is modular structure of subsystems and their interaction with each other. This is my modular structure, breaking of whole system into some subsystem and my modules. Now these modules, when they are interacting with each other, this thing is seen here. That is their relation and interaction. Modular structure of your subsystem. Whole system is broken into systems. Then in that system, not only two modules, in the particular system you are having so many modules. This is my subsystem number 1. Suppose this particular subsystem, these are having so many modules. So these modules are having interaction with each other. So this interaction or this communication with each other, that whole thing, whole process is being done in this high level design. Then, so mainly what thing is happening? From the whole system we are breaking it into small pieces. Why? So that we can easily work with those things. When you are working with the whole system, errors may be there. Maybe you can have different failures, different faults can be there, and security problem can be there. Your budget is there, your time complexity is there. When you're working with the whole system, maybe if some error comes, then what you have to deal with it with the whole system. Again, you have to create that one in the designing phase. As we have seen in the prototyping model or in the evolutionary model, that we are designing that at that time we were making the prototypes. So that thing is happening here only. Those particular things, that is the making of the prototype, designing of the prototype, then again making the particular evolutionary model. In that model we have seen we are making that particular design, again we are giving that to the customer is giving you that yes, okay, then again we are doing something. So that thing is going to be here in your designing phase. So you can see that when we are dealing with the whole system, then of course there can be a error, there can be a failure. There maybe your customer is not, he's not giving his consent, that is okay. So at that time we have again to deal with the whole system. So what we do here, we break the whole system into small modules, so that if any error comes or any failure comes, that will be coming to your particular module, you can easily correct that one. And if the modular system is okay, then any error comes, then it is with your subsystem, then you can correct that one also very easily, so that your whole system is not affected. You can easily correct your modules, specific modules, so that whole system is not affected by that one. Then, so this thing is done in our high level design. Now next level, that is our detailed level design. Third level, that is our highest level. What is the implementation part of system and subsystems of previous stages? Now we have seen here, we have broken the system. Now here we are implementing those systems and subsystems. Systems were, here we are working with system, here we are working with subsystem. So implementation of those system and subsystems. Now you have what here? You have done here with your system. Then you have broken it into subsystem and modules. That is also done. Now here you are implementing the whole part, that is with this and this. These parts you are implementing in your software. That detailed designing. Now you have done the detailing. Now the whole detailing is being implemented in your main software, in that detailed design phase. Some software you are taking, breaking it, subsystems, modules, all work done. Now you are implementing those things in your software. Detailed design. Then secondly, more details towards modules and their implementation. You have the modules now. There what we were doing, we were just breaking the systems into subsystems and modules, and we were working with their interaction with each other. Here what we will do, we will add some more interaction, we will see more communication. What is that? That is cohesion and coupling. Cohesion and coupling, what is that? We will see in next class in details. But mainly what is that? In cohesion, what we see, if the cohesion is high, then your system is good, better one. What is cohesion? Cohesion is the interaction between different modules. Okay, when inside a module, inside a particular module, there are some components. Again, inside the modules, there are some components are there. So interaction between those particular components inside the module. Okay, the interdependability between those particular components, that is cohesion inside a module. And what is coupling? Coupling is what? When two particular modules is there, the interdependability between those two particular modules is known as coupling. Then again repeat, what is that one? The interaction. See, I will show you here. Then you will be able to understand that one. Here, this is my system S1, and I am having here some subsystems. Suppose these three subsystems are there. That is SS1, SS2 and SS3. These are my subsystems. And now in those subsystems, now, so suppose here we have seen this the whole system, okay, S1. Now here we are having different subsystems, SS1, SS2, SS3. Now here suppose we are taking this particular subsystem SS1. What we are seeing here in this SS1, we are having three modules, M1, M2 and M3. Then here in M1, M2 and M3, these are my modules. The interaction between these things, first we are working with this in the architectural model, architectural design. Now in next what we are doing here, we are dealing with the subsystem, that is in a high level designing. What we were doing, we were interacting, we were seeing the interaction between these and the interaction among these. These thing was happening in the high level designing. Done. And in the third phase, what is happening here? More details, that is in between these modules, they are having some interaction. Done. This is known as coupling. This interaction between modules, and in these particular modules also some components are there. Interaction between these things are known as cohesion. This is what is more details about the modules, that is their interaction, more details about the interaction between your modules. This is the thing what is happening here in the highest level, that is the detailed level. Here more details towards module and their implementation. This is more details, that is the coupling and cohesion. Then also there are many types of coupling and cohesion. Many types. There are 7 types of coupling, cohesion, and 5 types of coupling that we will see in another class. But this is the main thing what is happening here. First level, whole system. Why I am repeating that one? Because every time whenever it comes, it's a topic of confusion. So that's why I am clearing your confusion, that in the first level what is happening, the whole system, we are working with the whole system. That is my system with some components. In second level, the interaction between this, I am breaking this whole system and these components into subsystems. And now I am working with these subsystems and the modules in between those subsystems. I am working with that one. Third level, what? Again, it is more complicated. That is, here, these two, we are taking all those things here, and these modules, more implementation of more interaction between these modules. That is the cohesion and coupling form. Interaction between the particular modules, that is your coupling, and what is the interaction between the components in between in that particular, suppose the particular module, in between those components, what is the interdependability, that is your cohesion. Okay, so these things are seen here. Now, logical structure of a module. What is my basic logical structure of my module? I am taking a module, then the whole logical structure of my module, how I am working in that module, what work have been done in that module, those things are basically seen here. Now we are working in the module phase. As you can see here, now we are working with the module phase. First system phase, subsystem phase, now my module phase. Means basic, just little basic. Modules are what? They are the basic system, basic thing of your whole system, whole software. So now we are working with that basic thing. Means the lowest level of your software. And interfaces of module communication, as I've already told you, coupling and cohesion. This is what are known as modular communication. So interaction between those modules, this communication whole thing, this is coming in this phase, that is my details phase. Clear? So we are just breaking the system. From level to level, we are breaking the system and going to the basic level of your software. That is your modular structure. Okay. Now what is modularization? Modularization, that is your next topic in between in this software. As you have already seen, nothing is there special in this. We have already seen what is cohesion, coupling, everything is there in your modularization. But we will see here what are the advantages, why we are breaking the whole system in modules. Okay, so first of all, the main thing is modularization. This is my new topic. Means breaking my system into module. That is breaking my whole system into some discrete modules. Okay, into some multiple and discrete interdependable module. They are independent. Okay, these are independent. They are working independently, individually. This module, suppose it is working something, this is working something, but they have some interaction. They are independent in their task. They are having independent task. Okay, independent task. But what is the main thing? Interaction. They are having some interaction. They are doing independent task. They are being executed. They are being compiled. Everything is done individually, separately. For every module. If I am working with this particular module M1, then I will compile this individually. I will execute this individually. Again for M2 same thing. But this interaction is there. Its output, maybe it is the input of this. So they are having some specific particular interaction is there. Their work. So what is this? This is mainly the divide and conquer rule is used here. I am dividing the whole system and I am conquering this particular subsystems, these modules. I am working with those modules. So these things is what is known as modularization. Okay, modules are being worked with in this particular aspect. In this aspect only you will see that coupling and cohesion. Now why we are breaking this in modules? What will happen? So let's see what are the advantages of this. Okay, the advantages of this modularization. Okay, first one is smaller components are better when you are working with smaller components or smaller parts of your system. So what will happen? When you are working with smaller components, they are easy to maintain. Okay, now easier to maintain how? If you are taking this particular small components, then you can easily execute them. If you are having any error, any kind of failure, you just correct that one particular module. You can easily maintain this thing. In case of maintenance also, when you are going to work with maintenance also, at that time also you will see that these basic designing, what you have done now in this designing phase, you can easily deal with those particular modules. In case specifically take that module, just change that one and you can implement that thing in your whole system. So like this, what will happen? The whole system is not affected at once. If some error comes, if some failure is there, then whole system is never affected at once when you are doing this, working with this modularization. Okay, so this thing is what? Smaller components and smaller parts. So easier to maintain, easier to work as well as and maintain. This is what is happening in your modularization. Again, you can break these things. You can divide particular modules, okay, for specific function. Specific function. This function aspect is there. When you are having these modules, you can easily divide those modules. Suppose these modules, they are working with some particular function. In my library management system, I have seen that one. When I was working with my input function and function phase, that was what I was giving the name of some author's book. So it was taking my input. That was a particular module. Second module, what it was doing, it was just transforming that one. Transforming the whole system, whatever I have told it, that is, I am giving the name of an author. It was what it was doing. It was the searching that name of that author, the particular book, the rack number, or where the book is, that whole thing. And that third module, what it was doing, it was giving me the number of that particular rack. It was generating the bill, or again those things, and giving me the details of my book so that I can find that one. So these are my different modules which are working independently. So this functional aspect you can easily work when you are using this modularization. Every particular module is functioning with a particular function. So these things is what is happening in this modularization. Then third things, component with higher cohesion, and I has already told you that cohesion and coupling. Okay, so these things, when they are better, cohesion will be better. If what is happening here, cohesion can be better when we have high cohesion, okay, and low coupling. So this kind of thing is better one. This kind of software is better. High cohesion, why? High cohesion because what? When you are having the module and the components there, they are highly connected with each other. So you can reuse that one. We have seen in RAD model, what we were doing, we were reusing those things. We were reusing particular modules, we were reusing the codes so that time can be saved. So in that kind of model, if cohesion is high, then you can easily reuse that one. Then again, next thing is what? Concurrency can be easily done. Concurrency, what is concurrency? We will see now. Now concurrency can be easily achieved. Okay, concurrency means when two subsystems, they are working parallelly in a particular instant of time. That can be achieved here very easily. And fifth one is our security purpose. That is, for any particular module, you can easily give the security. The security aspect can be dealt very easily in this module specific system. Okay, when you are breaking those things, you are having system particular security for your specific module. If this system is particular security, if by anything is challenged, then only that particular module is affected, not the whole system. So you can easily deal with that one. That is why for these whole things, these particular 5 advantages, we use this modularization, or we are breaking the whole system into different modules. It is very easy now, because if you are working with the whole system, you have to deal with the whole system. Again, if with some error, you have to work again you have to start the work as a fresh one. But when you are working in the module system, you can easily change the module. It is saving your time, saving your budget, everything. Okay, time and budget is also saved. That is also your advantage. Now, one thing which we have heard now, that is concurrency. Now we will see that one. Okay, so this is what is there in our module specific designing. Now concurrency, what is happening in this concurrency? We have seen there, concurrency can be easily achieved. I will give you example also. Concurrency. What is this concurrency? When my two subsystems, suppose this is my subsystem 1 and this is my subsystem 2, if these two are working parallelly, means these are working together side by side in a particular specific instant of time, in a particular specific instant time, okay, particular time. Suppose in this instant of time they are working together parallelly. This is also working, this is also working in my software system. Let's take the example. Suppose when you are working with a word processor, okay, simple word processor, what happens there? You can see whenever you are searching for, you are writing any word, you can see there, if you are writing any incorrect spelling, some spelling checker is there, right? Some spelling checker is there. that is your spelling checker processor. So what happens there? You are working with this in this word processor, but whenever you are writing a incorrect spelling, okay, certainly your spelling checker is showing you. So what is happening? How it is showing me that one? I am not again working with it. So this is what is happening in a word processor and spelling check system. Okay, so this thing, the whole thing which is going to be in your concurrency thing. The whole aspect of this thing are in your software designing phase. Now next day what we are going to do, we are going to see what is cohesion and coupling and the details of the different types of cohesion and coupling. Okay, till then, if you have any comments, if you have any queries, you write to the comment section, and please like and subscribe my channel so that I can give you more thing about different topics of technical education. Thank you. Bye.